Hello, students. This is Mrs. Nixon, and I'm here today to help you with day 23. First, let's take a look at the questions. The first question, number 1, says, suppose a force of 1,000 newtons is applied to both lifts. Use the graph to determine the lifting force of each lift. Well, let's take a look at this graph here, and it's titled hydraulic lifts. So we're talking about hydraulic lifts. And you've got on the x-axis here, you've got applied force, which is the force that you apply or the pressure, and it's measured in newtons, and you've got it in increments of 1,000 newtons. Then if you look at the y-axis, you've got the lifting force, and it's in increments of 2,000, and it's also measured in newtons. And then you've got two different lifts here. You've got lift A, the results of lift A, and then you've got the results of lift B. So you probably could answer that one right away without even going on, but we're going to go on and read the rest of the questions. For lift A, this is number 2, for lift A, how much force must be applied to lift a 12,000 Newton object? Well, here are the objects here, and this is lift A. So you would need to find lift A and then see how much force it would take to lift a 12,000 Newton object. Let's look at number 3. How much is the applied force multiplied for each lift? So you're going to compare the applied force to the lifting force. Now, remember the applied force is down here and the lifting force is here. So the best way to compare is always to just look at where they join. Here, 1,000 applied force becomes 2,000 in lifting force. And 2,000 in lifting force becomes 4,000 in 2,000 in applied force becomes 4,000 in lifting force. So that's for lift B. Then you can do the same thing with lift A, and you can find out the answer to the question. Do you see the pattern? That's what you're looking for there, is the pattern. Let's look at number 4. What does the rate of change or slope tell us about each lift? So now we're looking at the slope. This is the slope for lift A. This is the slope for lift B. What does it tell us about each lift? And the last question is, which lift would you choose if you wanted to produce the greater lifting force? And defend your answer. And then, as usual, we've got your sentence frames in here. If you need them, you can use them. You don't need to if you don't want to. But you could say, I would choose lift, and then you put A or B in there, whichever one you would choose, and then because. Don't forget to give your answer. All right, so I think you could answer these without even reading the prompt, which is what you would do if this were an Aspire question. However, we do have a little bit of time here, so let's read the prompt and find out what a hydraulic lift is. So read with me, please. A force is a push or a pull. Forces exist in many systems we use daily. One system is called a hydraulic system. You have probably seen them at a car shop, at a car repair shop, lifting a vehicle, or have felt a hydraulic system work when the brakes are pressed in the car. A hydraulic, and here it says hydro, is fluid. Okay, so anytime you see hydro as a prefix, it's talking about fluid or water or liquid. So a hydraulic uses liquids to transmit pressure in a system, turns liquids into pressure. A hydraulic system multiplies force by applying the force to a small surface area. The increase in pressure is then transmitted to another part of the fluid, which pushes on a larger surface area. So that's how hydraulic lift systems work. And I know several of you probably have seen hydraulic systems before. So graph 2.2 shows a hydraulic lift. This is going to be easy to do. You all can do this. So that's all you need to do. Answers 1 through 5 for today. Thank you. Bye-bye.